Hi, how's everybody doing today? Welcome to the first workshop of 1412, which is qualitative analysis. For the ones that don't know me, I'm Miss Mann, and I will be doing these workshops every Monday at 5:30. So we are going each week, we are going to go through the write-up of the experiment. Then we will do some practice problems to make you help understand the problems that you are going to encounter when you are going to do the pre-lab quiz. And after that, each week, we are going to go step by step, looking at the report that you will have to complete. So now that you saw me, Miss Mann, we are going to start. What is qualitative analysis? Qualitative analysis is the separation and identification of substances. That's simple. I was in charge of USDA laboratory in Washington, D.C. And in order to keep the accreditation for the USDA lab, we received an unknown sample every 3 months. And I was responsible to do the qualitative analysis, which is finding out which substances were in that unknown sample, and also the quantitative analysis, which means the reporting of how much toxic or how much chemicals we had in that sample. In my case, the USDA was testing pesticides in food. So when I receive the unknown, I have to say what kind of pesticides we had in that sample and how much. In your case, in your first experiment, you will have a reference sample of these 6 cations. You don't have to guess anymore. You know the periodic table, we have so many elements. But in this case, they're all cations. Cations, you remember, they're ions with a positive charge. So you will have a reference sample that will have sodium, potassium, ammonium, silver, copper +2, and bismuth +3. How are we going to separate and identify those 6 ions? It will be nice if we have a chemical reaction for each ion. But we don't have one individual chemical reaction that can identify each individual ion. What we do is we separate the ions that are similar in chemical properties, and then once we separate them in groups, we use individual chemical reactions to identify the substance. So what is a chemical reaction that helps us identify the ion? Well, let's say we have a test tube. Imagine you are in the lab and you have all these 6 cations there. What you want is to add a substance or a reagent or any reactant that will give you a signal that will change the color, or a gas will evolve, or you will smell some, or the pH will change, some kind of signal that will let you say, oh, I have this ion. So in our case, the first thing we are going to do is to learn different chemical reactions that will identify these 6 cations. And then you will be given a sample that we have only 3 unknowns, not 6. And according to the signals or the reactions that you obtain for these 6 reference samples, you will say, okay, I have sodium or I don't have sodium, according to the chemical reaction that you obtain for your unknown. Any questions there?
So where are those reactions? I'm sorry.
Say it again.
Where are the reactions?
Now we're going to go over each individual reaction.
Oh, okay, got you.
We're going to see that. Basically, I'm just giving you a general idea of what is this experiment about. This experiment in general is you will have a reference sample with 6 ions. That's it. And you will have to learn the 6 chemical reactions that will identify these ions. Basically, you won't have 6, you will have 12. You will have one general reaction and then another one that we call confirmation reaction. So we will go over each one individually. And then what I was saying is that because you are not in the lab, you will be given in the report, you will be given the signals of your unknown. But according to the signals that you are given, you will say, I have these 3 ions. You will have to report which are the 3 ions that you have in your unknown. Does it make sense?
Yes, ma'am.
Okay, so let's go over first the reactions, because you will have to kind of learn the reactions for each individual of the 6. The first one is sodium. You are going to test sodium and potassium. Sodium and potassium, there are not many chemical reactions that you can do. If you remember from solubility rules, all the salts from sodium group 1 and potassium are soluble. So we are going to perform for this sample, we are going to do a flame test. So basically, all we are going to do is to dip the a metal basically in the sample, and then we are going to bring it to the flame. And we know that the sodium will produce a yellow flame. So let me see here. Oh, it's not here. So you know that you have the flame. This is you will have a Benzer burner. And you know that this part of the flame is blue. But when you put a stick that is dipped in sodium, the flame will change the color and you will see a yellow color. The sodium produces a very intense yellow flame. The color is intense, and the problem with sodium is that if you have another ion that will give you a different color, it can mask the color of the other ion. So you have to dip it in acid, you have to clean it very well in order to see the next ion. So that is basically how we are going to test sodium. And how are we going to test potassium? Potassium produces a lavender flame. Instead of yellow, a lavender. The problem is that if you have sodium, it will mask the lavender color of the potassium. And when you are in a lab, you don't see it. So the way we test potassium in the lab is looking at the flame through a cobalt blue glass. So you put a cobalt blue glass, and then the blue glass will absorb the yellow color of the sodium and transmit the lavender color of the potassium. So this is basically how we are going to see potassium. Potassium is a little difficult to see because the color is it doesn't last long, and you will have to test it with a reference, with a sample that you really know that it has potassium. You have to pretend that you are in the lab. I know it's difficult, but you will need to learn all these little things, even though you don't see the experiment. And that is the hardest part. How are we going to detect ammonium? Ammonium here, NH4+. Ammonium is a weak acid. So when we add sodium hydroxide, here is the reaction. No, it's not here. When we add sodium hydroxide, it's actually in reverse. Ammonium plus sodium hydroxide, look at it in this way, produces a gas that is ammonia. So how are we going to see it? Let me see if there is here a little drawing of the setup of the experiment. Okay, not here. Okay, right here. This is, if you are in the lab, this is what you are going to do. So basically, you have the sample here of the ammonium salt, and you add the sodium hydroxide. So we said that if you have a salt of ammonium and you add a base, let's say sodium hydroxide here, you will have ammonia that is a gas plus water. How do you know that you have these vapors here that go up? First of all, the smell of ammonia, this is ammonia. And this one is ammonium. Remember, you might see a question there in the quiz. So when you have the vapors of ammonia that are going up as soon as you add the sodium hydroxide, here what you have is a red litmus paper. You remember from Chem 1 that when you have an acid, the blue litmus paper turns red. But if you have a base, the red litmus paper turns blue. In this case, this is an acid, a weak acid, and the ammonia will turn the moistened litmus paper red, it will turn it blue. So that will be the reaction that we are going to perform in order to decide if we have ammonium or not. So from the 6 cation, we are going to go slowly. The next one is the test for the silver ion. If you remember from last semester, the silver ion precipitates with hydrochloric acid and produces let me see if I have the reactions here to show it to you. Okay, silver ion. When you add hydrochloric acid, no, the previous one. Okay, so right here, no. Okay, that's okay. The first reaction, when you have silver ions and you add hydrochloric acid, the first thing that will happen is a white precipitate that is a solid of silver chloride. So if you have the ion in the solution and you add hydrochloric acid, you are going to see in the tube a white precipitate, or the test tube is going to become opaque. Why is this second reaction here? Because they want to tell you that if you add too much acid, it's going to dissolve, forming this complex ion. So this experiment is a little bit about learning the different reactions to identify the 6 ions. These and next experiments are pretty simple, and then as you make progress, it becomes more complicated. But let's start from this one. This is just basically learning the reactions. And then which other reaction is going, let's say you add hydrochloric acid and you obtained the white precipitate. And then you're gonna say, am I sure that I have silver? So you have a second reaction, which is adding ammonia. When you add ammonia, if the precipitate, the white precipitate was silver chloride, is going to dissolve. Is going to disappear, the white precipitate, because with ammonia, they form a very stable complex ion. Yes, any questions so far? Yvonne, any questions?
Yeah. So I got the white precipitate. I'm kind of confused by the So the second reaction is checking what?
The second, okay. So sometimes one reaction is not enough because you can have 2 different cations that give you a white precipitate. So usually in chemistry, you want to confirm. The second reaction is a confirmatory reaction. So the first, you obtain the white precipitate, and then you add ammonia. When you add ammonia to the test tube, let's say you have the test tube and you have a precipitate, and you add ammonia, all the white that was here disappear, and you end up with a clear solution. Then it's another indication, it's a confirmatory test that you have silver, because the silver with ammonia forms this complex, which is silver, ammonia, 2 plus. Does it make sense?
Yeah, I get it.
It's basically a second test. So you have the solid here. You add ammonia, and the precipitate dissolves. But what happened? The precipitate dissolved to form this complex ion, which is this one. But then, if you want another confirmation, this complex is not stable in acid. So what happens is that you add an acid, and again, it's not stable, and you obtain again the precipitate. So let's say you have the precipitate, you add ammonia, and the white precipitate dissolves. But if you add an acid, the precipitate forms again. That's why. Why it forms again? Because what happens is that the ammonia, see here the ammonia that was combined with the silver, combines with the acid. So basically the acid is removing the ammonia, so we obtain the acid, the precipitate, the silver chloride again.
Okay.
It's another confirmation test.
Okay.
And you are going to go over this, and all the reactions are written here in the procedure. And then we also are going to check these two, copper +2 and bismuth +3. The reactions that we are going to look at, let me see here, is this first reaction. We are not going to do it in the lab. So basically, we are going to test the copper and the bismuth adding ammonia, NH3. So what happens is, let's say I have a test tube with two ions, bismuth and copper +2. I need to separate those ions, and I need to identify those ions, and they are together. So I add ammonia. What happens? If you are in the lab, the bismuth reacts with the ammonia and forms a solid, bismuth hydroxide, and this is a white solid. And the copper also reacts with ammonia to form this soluble complex ion that is blue. So if you have these two, you're going to end up with a white precipitate and here a blue solution. The solution is going to turn blue when you add the ammonia. When you have a solid and a liquid, if you are in the lab, you centrifuge that, and you can separate the solid from the liquid. So then you are going to perform two other confirmatory tests. For the copper, that is a blue solution, you are going to add hexacyanoferrate, this compound, and the color, this was blue, is going to change into a red-brown precipitate. And then you're going to say, oh, if this is blue and the blue turns red, yes, I have copper. And what happens with the bismuth? With the bismuth, you also want a confirmatory test. So what you do is you have the white, this was a white solid, and you are going to add sodium stannite. The sodium stannite basically is tin plus 2. It's a redox reaction. So what happens if the white, when you add that, the white precipitate turns black. So this is a confirmatory test. When you add sodium stannite to the white precipitate of bismuth, it turns black because it forms bismuth 0. So let me now make it, try to clarify at the end of the, let me see. Let me share this page. Before we go to the practice problems, I want to make sure that everything is clear. So this is a basically a summary, or they call it a flow diagram of your practice. So in theory, you are supposed to read the all the procedure and then be able to fill this. I just want to go over just as a summary before we start the practice problems. So we said at the beginning that you have 6 cations that you are going to identify and separate. And we said that we divide the cations in different groups. So one group is going to be these 3. The silver, the copper, and the bismuth. When you read the procedure, because it's a lot of reactions that you need to read, you will see that you are going to add hydrochloric acid to this sample, 6 molar. And we just seen that hydrochloric acid with silver produces silver chloride. That is a white precipitate. So you are going to have the solid, and the other 2, the copper and the bismuth, are going to stay in the liquid. When you centrifuge, like you spin it like your washing machine, you separate the solid from the liquid. The solid stays in the bottom and the liquid stays up, and you can decant, and the precipitate of silver chloride stays at the bottom. And then what do you do to make sure that you have silver? We said that we are going to do a confirmation test. So we add ammonia, and we said that when we add ammonia to the precipitate dissolves, right? Sorry, it's hard to write with the mouse. So this is what we obtain when we dissolve the white precipitate of silver chloride with ammonia. And then we want to confirm. So what do? We add an acid, we said. When you read the procedure, you will see you use nitric acid, and you come back with the precipitate. What happened with these 2? We just seen some of the reactions. The first thing you do, you add, this is ammonia. It's the same thing as ammonium hydroxide. You can write it like NH3 or NH4OH, which is basically with 1 water. So what happens? You remember that when you add ammonium, the bismuth is going to give you bismuth hydroxide. That is a solid. And the liquid, what is going to be in the liquid? It forms this complex that we said is blue. It's deep blue. So this is just a little summary. And then we need two confirmatory tests, right? When we add sodium stannite to the white precipitate, we obtain a black solid bismuth. And what happens when we add hexacyanoferrate to the blue? We obtain this red brown. So these are all signals that in our sample we had copper. And on this side that we have sodium, potassium, and ammonium, the ammonium, all we did was to test it when I show you that we add sodium hydroxide. And when you add a base to a weak acid, we tested the ammonium with the litmus paper. And these two, the sodium and the potassium here, what did we do? In both, we did a flame. And you remember that the sodium gives you a yellow flame and the potassium gives you a lavender flame. And we said that it's a fleeting flame. And we have to look at it through the cobalt, otherwise we will see the yellow that masks the color. Any questions so far?
No.
Okay. When you have to, in the report, I'll show you later, when you will have to write the reactions, luckily, all the reactions are in your write-up. So you can look at them, the copper with ammonia, what is the formula of this blue complex, what is the reaction of this. So you have all the reaction. There is no need for me actually to write them because you have all that information. It will be more useful if we do some practice problems. So let's go and do some practice problems. Before you do your quiz, it will be helpful to answer this. So let's look at, you can zoom in your computer if you cannot read the question. So can you read the question? So any of you?
Yeah, I can read number one.
Thank you.
Which two elements are tested in the flame, and what is the color flame produced in each element?
Okay. So what would be the answer for that?
The first answer would be when we were testing with the flame and we used where is it? And when their sodium was there, it turned into a Yellow flame.
Very good. So which two elements are tested in the flame? One is sodium, and the other?
The other one was potassium.
Yeah.
Very good. The other one is potassium. What is the color of the potassium?
That
Lavender.
would make a lavender flame.
Very,
but
very
blue top.
excellent. Okay, so we remember that these are similar of what you are going to encounter when you start doing the pre-lab quiz. So that's why. And then you will have to remember some other things that we briefly talked about, that the yellow of the sodium is very persistent and sometimes can contaminate. Any traces of sodium can contaminate another one, so you need to clean it very well before you test another element. And we said regarding the potassium, we mentioned that we need to use sometimes a cobalt glass, a blue cobalt glass, to absorb the yellow color, and then we can see the lavender. And also we talk about that is very fast. Sometimes you see a little fast lavender flame, but you're not sure. So what people do is bring a sample that you know for sure is potassium. And then what happens is that you check your unknown with that reference that you know for sure is potassium. Those are all the things that we do in the lab in order to confirm the presence of potassium that is not that easy to see. How about the second question? What are the 6 cations we are identifying in this experiment?
Sodium, potassium, ammonium, silver, copper, and bismuth.
Very good. Very good. Exactly. And copper +2. Okay, so what is the change in color that occurs when aqueous ammonia is added to a solution containing copper +2 ions? Do you remember?
Blue.
When you have, yes, exactly. When you have copper, all these reactions actually are there for you in the write-up. But exactly, you are going to have this complex for ammonia +2, and what they are asking is the change in color. So this is blue. And the next question, what is the change in color that we use to identify copper +2 when potassium hexacyanoferrate is added to the previous solution of the complex of copper and ammonia? Do you remember the color?
Red, brown.
That one was red brown.
Yes, very good, red brown. Okay, I don't need to write the reaction, you have actually that. The next question. Somebody wants to read it?
You can go, Amanda.
Yeah, I'll read it. It says, what is the chemical reaction and color change when aqueous ammonia is added to a solution containing bismuth?
Okay, do you remember that?
Black.
Let's see. What is the chemical reaction and color change when aqueous ammonia is added to the solution containing bismuth? So this is the first thing. We have an ion that has bismuth. And the first thing we do is adding ammonia. So basically the bismuth plus the ammonia, we actually can write this. Ammonia is the same as ammonium hydroxide. It's basically a weak base. So what happens? This OH, I wrote it this way, it forms the bismuth hydroxide. And this is a solid. This is a white precipitate. So the first thing, when you have the copper and the bismuth and you want to separate them, you add ammonia. And then what happens is that this one is a white solid and the copper stays blue in solution. So this is the first reaction. And the one that you were talking is the next one. Is what is the reaction and color change when you add sodium stannite to the white bismuth hydroxide? Then is what you mentioned before.
Black.
Is black. Exactly. It's a redox reaction. Basically, the white of the reduces into bismuth zero, bismuth methyl. And this is actually black. And this is white. You are going to refresh, but this is just. And then the last one. How are we identifying ammonium in this experiment? You remember that we said that ammonium is a weak acid. So we have ammonium and we add a base. So we add 2 milliliters of sodium hydroxide. When you read the procedure, you will read this and it's going to form the ammonium is going to form the gas ammonia plus water. And this one is basic. This is an acid, weak acid. And this is basic, the gas. So it will turn the red litmus paper when it's humid, when it's moisture, into blue. Any questions so far?
No.
Okay. So now we, since this experiment is easy, but you will have to remember a few reactions, but there is no complication, we will go over and share the report that you will have to complete after the doing the quiz. Did you try to do the quiz already or not yet?
Not yet.
Okay. So read everything and watch all the videos, but this, I hope it will help. So this is the report that you are going to see. because you are not in the lab, you will be given all the information. It will say, if you are in the lab, it's a little harder because you have to do the experiment and take notes. Basically, you do the experiment, you take notes, and after studying the reaction, you write the chemical reactions. But in this case, all this information is given. So they tell you that the sodium is yellow-orange, all this is given. So all you have to do is enter the chemical equation for this test. So in this case, what are you writing? You know that they give you, it says evidence of chemical change. Well, you have the smell of the ammonia, and also you see the blue litmus paper. The red turns blue. So all they are asking is basically to write the reaction. I won't write all of them because you actually have them. So I'm not gonna make waste your time. So this is a simple report. Not all reports. Some reports will take a lot of time from you and calculations and use Excel, but this one is just to look at the reactions. So here, what else you will have to do? Enter the chemical equations for the test and the confirmation test. So again, chemical equation for main copper test, you have them all in the write-up. So here, that's basically all is going to ask. And then at the end, you will have to say, now you know what are the signals, are the changes in color for the 6 ions. So let's look at this one, and you will you will have to say which one is your unknown. Your unknown will have only 3. Only 3. So let's look at this one. Each example is different. So this is your unknown, and it says a purple pink color flame was observed in the flame test. So then it's going to ask, what do you think you have? Do you have, let me see, a purple pink were observed in the flame test. A purple pink color was observed in the flame test. A yellow color flame was observed. So then you will say, if you have potassium or if you have sodium, and then test for presence of ammonia. Well, actually, I don't want to show you. I mean, the one that I did, but litmus paper turned blue. What does that mean?
It means it has ammonia.
Exactly. Then adding hydrochloric acid, no precipitate form, or a white precipitate form. These actually are all the possibilities, right? I don't want to confuse you, but if you see a white precipitate, what do you have? When you add hydrochloric acid?
Silver, right?
Exactly. And then when you have, let's say, copper, and you have bismuth, and you add, let's say, you add ammonium. If you see a white precipitate, your sample has bismuth. If you see a blue solution, you will have copper. So basically, you can always look back at the reactions and remember, and you will have only 3 out of the 6. And basically, it's very simple. All the reactions are there. Not sure if you have any questions regarding this experiment.
No, that's it.
Okay, so I will stop.
Question.
Yes.
That last bullet point, does that, like, what does that mean? That you added HCl and then that other substance and then HCl again? Is that what it's asking, or is that what it's saying?
No, no, no. The procedure will be, let me show you here. Okay, experiment, share. Okay. No, this is what you are going to do, what we talked about before. So what did you ask me? Sorry.
Oh no, I was confusing 2 of the reactions, but I see.
Okay. Okay. Yeah, this is good to have it on hand and to complete it as I did before. And then, yeah, you will have it clear. But it's going to be very, very simple, I hope. So I will stop the recording and I will stay just in case you want to talk about these experiments or if you have other questions. And thank you for coming.